Howdy students, I've got a shell example here for you guys. So today we're asked to find the volume of the solid formed by rotating the graph x squared about the line x equals 1. And because we're rotating this about an x-axis, we're going to have to integrate with respect to y. And so what I've done is I've gone ahead and converted our function here, giving us x equals the square root of y. And so the first thing we need to talk about is how do we deal with this axis of rotation not being x equals 0 or y equals 0. All right, so what we see is this point of intersection is this distance away from our y-axis. And so what we can do is we can say, first, I'm going to set 1 from x equals 1 equal to the square root of y, and we see that these two are equal only if y equals 1. So I'm going to say that this point here is 1, 1. And then what we can do is, in mathematics, we can take the distance between this point and this point to set up our function. And that looks like the absolute value. And so the absolute value from 1 to square root of y is the distance from here to here, here to here, via Pythagorean's theorem. Not to bombard you guys with the analysis, but this is how we determine distance between points. Okay, so now that that has been established, this is going to be the function that we use for our shell method, the integral a to b 2 pi, pi f of x times x dx, or in our case, because we're integrating about the y, 2 pi a to b f of y times y dy. So substituting this into here, we get 2 pi integral, and again, we go from, now we go from 0 to 1 from this here. So our bounds of integration are 0 to 1 of the absolute value of 1 minus square root y times y dy. And the nice thing is that we only have to take one side of this integral, because if f of y is less than or equal to 1, we would get 1 minus square root y. And if f of y is greater than or equal to 1, we would get square root y minus 1. And because we don't need anything past x equals 1, we can just take this term, and we don't have to worry about the other one. Okay? So, knowing that, I'm going to pull this down here and say 2 pi integral 0 to 1 of, and I'm going to drop the absolute value bars, 1 minus square root y times y dy. All right? And then one more thing I'm going to do really quick is I'm going to change this y to the 1/2. This is the 1. This is y to the 0. Distributing this into our parentheses, we can just add our powers. So we get 2 pi integral 0 to 1 of y minus y to the 3/2, right? Because 1/2 plus 1 equals 3/2. Okay, dy. And the last thing we need to do is just evaluate this integral. So we get 2 pi y squared over 2 minus 3/2 plus 1 over 3/2 plus 1 gives us y 5/2 over 5/2, which gives us 2/5 y to the 5/2 on the bounds from 0 to 1. Substituting in our bounds, we see that if we substitute in 0 here or 0 here, we get 0 for both expressions. So then I would just get 2 pi 1 squared over 2 minus 2 over 5 times 1 to the 5/2, which gives us 2 pi 1/2 minus 2/5. And finding a common denominator between these two, I'm going to multiply this by 5 over 5, and this by 2 over 2, giving me 2 pi 5 over 10 minus 4 over 10, giving me 1 over 10 times 2 pi, or 2 pi over 10, which simplifies to pi over 5.